Okay, so this is 8-4. I think this is going to be the friendliest section in Chapter 8. And we're going to do operations with matrices. Specifically, we're going to add, subtract, and multiply matrices and do something else called scalar multiplication. So in this section, for what it's worth, we're going to do matrix arithmetic or matrix algebra. We're going to add matrices, subtract matrices, multiply matrices, and do something called scalar multiplication of matrices. None of them are terribly hard. This is probably the hardest to do by hand. It's not horrible. Notice I don't write divide. There's no definition for division with matrices. I've never seen matrice division defined or done, so that we won't do that. To get started with this section, I have 6 matrices that I'm going to enter on my calculator, and I need to know the sizes of these. This matrix A has 2 rows and 2 columns, so I'm going to call it a 2 by 2 matrice. B also has 2 rows and 2 columns. It's a 2 by 2 matrice. C has 3 rows and 3 columns. Columns go vertically, rows go horizontally. I call C a 3 by 3 matrix. D has the same dimensions as C. It has 3 rows and 3 columns. E has 2 rows. This going horizontally as a row, that going horizontally as a row. So there's 2 rows. It has 3 columns. And I'm going to call E a 2 by 3 matrix when I go to enter it on my calculator. F has 1, 2, 3 rows and 1, 2 columns. I'm going to call F a 3 by 2 matrix. So I'm going to take a minute to get all those 6 matrices in my calculator. And so far we've only defined matrices as A. Now I'm going to be able to use the other letters on my calculator. So I'm going to go second matrix. Find a nice spot for this. Second matrix, go to edit. And let me go backwards. Let me do the F first. And I probably have already done the F, but I'll do it again. So if you hit your arrows, matter of fact, let me just clear this calculator out. Program, I don't want to do that then. Second matrix, edit, go down to letter F. So I have the F and the edit simultaneously highlighted. You don't have to have anything in the column next to the F. I'm going to hit enter. I'm going to type in 3, enter, 2, enter, and just type in the numbers, even though I've already done it because I wrote the key for this section a little bit ago. So I'm going to enter matrix F the way it needs to look. First column has 1, 5, 6. Second column has negative 2, 2, 7. After I get the matrix entered, I hit second and quit. I'll do the same thing for E, D, C, B, and A. Specifically, I'll go second matrix, arrow over to the edit, and then down to the matrix that you want to enter. So if I want to enter matrix E, I need to have the edit highlighted and the E highlighted. And again, you might not have anything next to this, or you might have some other matrix in there. Whatever matrix is in there, we can type over. So I'm going to hit enter when I have the names in the E highlighted. I'll type 2, enter, 3, enter, and then just type the entries of the matrix. It's no different to enter a matrix, well, unless you do something stupid. There's no different entering, really. Oh, I see here. There's no difference entering this matrix as any matrix that we've done before, other than I called it matrix E. Second quit when you're done, then second matrix, simultaneously get the edit in the right-hand column up top and the D highlighted simultaneously. Type in, the 3 by 3, then type in the entries 3, 2, 0, 3, negative 1, 4, 1, negative 5, and 6. Once you have the matrix in, second and quit out, then second matrix again, arrow right to the edit, get simultaneously the C and the edit highlighted. Once you have the C and the edit highlighted, you'll type in 3 by 3, enter in the matrix, the way it's presented in the section. So 1, 0, -1 for the top row, 7, 2, 4 for the second, 2, 3, -5 for the third. When you're done, you second and quit. Then second matrix edit, get the B and the names highlighted, hit enter, type in 2 by 2, enter the 4 numbers. Once you have the 4 numbers in, second and quit. And then lastly, second matrix, get the A and the edit highlighted, type in type in 2 by 2, and then -2, 4, 3, and 1. So you should be able to get the matrices in. Having the matrices in will make it easier to check these answers via your calculator. The first 2 problems on this sheet, problems 2 and 4, are scalar multiplication. To do problem 2 on my calculator, I'm going to type the number 5. That's the number that's to the left of the B there. So I'm trying to find, just in case this is too small, I'm trying to find 5B. And that's easy to do on my calculator. I type the number 5 for the 5. Then I hit second in matrix, leave the names tab up top darkened, arrow down to the 2, which is next to the B, and you'll see my calculator displays 5B, more or less, the same that I've displayed here. And so the answer to problem 2, the scalar multiplication, multiplying matrix B by 5, you get 20, 25, 5, and 10. If I wanted to do that by hand, it's not hard at all to do by hand. To do 5 times matrix B, that's just doing 5 times the matrix 4, 5, 1, 2. And to do that, you just multiply each component by 5. I'm going to multiply the 5 by the 4, the 5 by the 5, the 5 by the 1, and the 5 by the 2. And that's going to give me 20, 25, 5, and 10. So scalar multiplication, when you have a number written to the left of a matrix name, that just means to multiply every component in that matrix by that number. So if I wanted to do -4 times matrix E, that would be the same as -4 times the matrix -3, 2, 2, 5, -1, and 3. I'm going to do this by hand, and then I'm going to check it on my calculator. Now I'm just going to multiply every single number in this by -3. Be careful with my signs, and that's going to lead me to my answer. So I'm going to go -4 times -3, the 2 negatives multiply to be a positive, and I get a 12. -4 times +2 is a -8. Another -4 times +2 is a -8. -4 times +5 is a -20. -4 times -1 is +4. -4 times +3 is -12. I think that's the right answer for the scalar multiplication -4 times E. I'm going to check on my calculator by getting my calculator. First I'm going to type the -4, and then I'm going to go second matrix and simultaneously have the names in the E highlighted because I'm trying to find -4 times matrix E. When I hit enter, that tells me it's going to take -4 and multiply it by matrix E. And when I hit enter, I see 12, -8, 8, 24, -12. Not that you probably could see that perfectly, but it's exactly what I've written. So scalar multiplication is probably the easiest operation that we do with matrices. It's fairly simple, straightforward. You don't really need a calculator to do scalar multiplication. If you could do the multiplication without a calculator, that's completely fine. The next operations we're doing are adding and subtracting, and they're in a combination of adding and scalar multiplication, or subtracting and scalar multiplication. Problem C6 wants me to take matrix C and add matrix D. Matrix addition is also reasonably easy. It's intuitively defined, I think. So I'm going to take matrix, pull up a new sheet of paper because I started writing the matrix wrong. To do matrix C plus matrix D, I need to take the matrix C, which is 1, 0, -1, 7, 2, 4, 2, 3, -5, and add it to matrix D, which is 3, 2, 0, 4, -1, 3, 1, -5, 6. Matrix addition, you just do the component, you add the components. So this right here in the upper left-hand corner, I'm going to add the 1 and the 3 that are in the same spots. Upper middle, I'm going to add the 0 and the 2 that are in the same spots. Upper right, I'm going to add the -1 and the 0 that are in the same positions. Move down to the second row, I'm going to add 7 and 4 that are both in the second row, first column. And then take the 2 that's smack dab in the middle, add it to the -1 that's in the middle. So I'm going to go 2 plus -1. And then 4 plus 3. Bottom row, 2 plus 1. 3 plus -5. And -5 plus 6. So that's the beginnings of my addition. I replace the matrix names with what they're equal to. Matrix addition, you add components that are in the same position. Now I'm just going to do the addition or subtraction when the signs are opposite. So the first one, 1 plus 3 is 4. So this is going to give me the answer to what C plus D is. 0 plus 2 is 2. -1 plus 0 is -1. 7 plus 4 is 11. 2 plus -1 is 1. 4 3 is 7. 2 plus 1 is 3. 3 plus -5 is -2. -5 plus 6 is 1. That's supposed to be the answer to what matrix C plus D is. Check this on my calculator, super easy. Just have to use the matrix names twice. I won't have to use any of the math features of the matrices. So to check this answer on my calculator, I'd go, let me clear the screen out, hitting the clear button. I'm going to go second matrix. First get the names in the C highlighted to get the C, and then hit enter, and then a plus sign, and then second in matrix again, and now I'll get the names in the left-hand column and the D highlighted. This looks more or less like the problem, other than my calculator puts the little brackets to emphasize that C and D are matrices, and I don't have that matrix notation around the C and the D, but it's okay. When I hit enter, I hope to see exactly this matrix. So I'm going to check. So see 4, 2, -1, 11, 1, 7, 3, -2, 1. So my answer is perfect. It matches up with my calculator, spot on. So that's problem 6 for what that's worth. Problem 8's a blended problem. It wants me to do 2C plus 6D. So problem 8 asks me to do 2C plus 6D. So that would mean to take 2 times the C matrix, which is 1, 0, -1, 7, 2, 4, 2, 3, -5, and then add that to 6 times the D matrix, which is 3, 2, 0, 4, -1, 3, 1, -5, 6. I'm going to do the scalar multiplication by hand first and then do the addition. The scalar multiplication of 2C, I multiply everything in the C matrix by 2. 1 times 2 is 2, 0 times 2 is 0, 2 times -1 is -2, 7 times 2 is 14, 2 times 2 is 4, 2 times 4 is 8, 2 times 2 is 4, 2 times 3 is 6, 2 times -5 is -10. Now I'm going to do the scalar multiplication of the D matrix by 6. 6 times 3 is 18, 6 times 2 is 12, 6 times 0 is 0, 6 times 4 is 24, 6 times -1 is -6, 6 times 3 is 18, 6 times 1 is 6, 6 times -5 is -30, 6 times 6 is 36. So that's the scalar multiplication. I have to do that before I do the addition. Now I'm going to do the addition. In the upper left, I'm going to go 2 plus 18, and then 0 plus 12, and then -2 plus 0. Middle row, 14 plus 24, 4 plus negative 6 in the center, 8 plus 18, I'm just taking the like positions and adding them. Bottom, 4 plus 6, 6 plus negative 30, and negative 10 plus 36. So I'm ready to write my answer after I figure out what this equals to. Upper left, 2 plus 18 is 20. 0 plus 12 is 12. Negative 2 plus 0 is negative 2. Middle, 14 plus 24 is 38. 4 plus negative 6 is negative 2. 8 and 18 is 26. Bottom, 4 plus 6 is 10. 6 plus negative 30 is negative 24. Negative 10 plus 36 is another 26. I'm going to check this on my calculator. Real easy to do. Basically, I'm going to make my calculator look just like that, except the C and the D are going to have the matrix brackets around them. So I'm going to see if I can generate that answer. I'm going to go 2 first, and then second matrix. Simultaneously have the names in the C highlighted and hit enter. So that's the 2C part of the problem. Hit my plus key, type the number 6, and then second matrix, get the D in the names highlighted at the same time and hit enter, and then hit enter again, and I see 20, 12, negative 2, 38, negative 2, 26, 10, negative 24, and 26. So I've done perfectly with my answer to number 8. So it's a combination of scalar multiplication and addition, just like in regular arithmetic. Multiplication gets done before addition. Scalar multiplication will get done before addition as well. 10's a scalar multiplication and subtraction. It's not terribly difficult. Subtraction really isn't any different than addition. So 10, I want to do 5 times matrix C minus 4 times matrix D. So this is going to be 5 times matrix C, which is 1, 7, 2, 0, 2, 3, negative 1, 4, negative 5, and then minus 4 times matrix D, 3, 4, 1, 2, negative 1, negative 5, 0, 3, 6. I'm going to do the scalar multiplication. First, I'm going to multiply everything by 5. I'm going to get 5, 0, negative 5, 35, 10, 20, 10, 15, and negative 25. I have options with the second one. I could multiply everything by negative 4. If I multiply by a negative 4, I have to change the sign to plus. Or I could just multiply by 4 and leave the sign minus, and that's what I'm going to do. I'm going to leave the minus sign. I'm just going to multiply by 4. So I'm going to go 4 times 3 is 12, 4 times 2 is 8, 4 times 0 is 0, 4 times 4 is 16, then negative 4, 12, 4, negative 20, and 24. So this is probably the preferred way to do this by hand. I haven't taken into account the negative yet. Like I said, if you took account to the negative and you had negative 12, negative 8, negative 16, positive 4, your sign here should be a plus, because they've already taken into account that negative. So I pretend that I ignore that sign when I do the scalar multiplication. Now I'm going to do the subtraction. To do subtraction, it's no different than addition. I'm going to subtract the components in their positions. So in the upper left, I'm going to go 5 minus 12. Upper middle, I'm going to go 0 minus 8. Top right, I'm going to go negative 5 minus 0. Second row, I'm going to start off with a 35 minus 16, just subtracting the pieces in the right positions. And then a 10 minus negative 4 in the middle, 20 minus 12 to finish out the middle row. Bottom row, 10 minus 4, 15 minus negative 20, and then negative 25 minus 24. If I can't do any of the multiplication or subtraction or addition in my head, then it would make sense just to use my calculator for the whole procedure. So lastly, I'm going to get my answer. I can do all these subtractions, and some of them turn out to be additions in my head. 5 minus 12 is negative 7. 0 minus 8 is negative 8. Negative 5 minus 0 is negative 5. 35 minus 16, I think, is 19. Here, the double negative, 10 minus negative 4, the double negative turns to a plus. You really get 10 plus 4, which is 14. 20 minus 12 is 8. 10 minus 4 is 6. Another double negative that I think of as a plus. 15 plus 20 is 35. Minus 25 minus 24 is minus 49. Should be able to do this on my calculator just like the last problem. So I'm going to go clear this out just to free up my screen. 5, and then second matrix. Get the C in the names highlighted and hit enter. Then use the minus key, that's above the plus, below the times. And then 4, and then second matrix, names D, and hit enter. I see negative 7, negative 8, negative 5, 19, 14, 8, 6, 35, negative 49. So my calculator's answer matches up with what I did by hand, so I'm content that I'm correct. Next problem wants me to take matrix B and add it to matrix D. So I'll set that up. So to do B plus D, that's going to be B is 4, 5, 1, 2. I'm going to add that to matrix D, which is 3, 2, 0, 4, negative 1, 3, 1, negative 5, 6. This isn't going to be possible. In order to add two matrices, you have to have a one-to-one correspondence. So like this 4 would match up with this 3, that 5 would match up with the 2, the 1 with the 4, this 2 with the negative 1, but there's nothing to match up with any of these, so this is just going to be not possible. In order to add two matrices, they have to be the same size. B is 2 by 2, C is 3 by 3. You can't add a 2 by 2 with a 3 by 3 matrix. You have to have a one-to-one correspondence in the size. And my calculator will know that for me too. If I try to do this on my calculator, it did second matrix, first names and B highlighted and hit enter, and then plus second matrix, after that names and D highlighted together. And I see B plus D, that's essentially what the problem is, other than my calculator used the matrices brackets. I don't have those by hand. My calculator is going to say dimension mismatch probably when I hit enter, meaning that it's not possible. It's not possible because the matrices aren't the same size, essentially. See, I see error dim mismatch. That means dimension mismatch. Means either I need to make B bigger or D smaller to make them addable. So it's not possible to add matrices unless they're exactly the same size, meaning they have the same dimensions. We've been working with C and D. C and D are both 3 by 3 matrices, so those can be added to each other. And the beautiful thing about matrices and the algebra, my calculator just chews them straight up, and it's not an issue on my calculator at all. The last of the easy kind of problems to do E plus F. E is negative 3, 2, 2, 5, negative 1, 3. F is 1, negative 2, 5, 2, 6, 7. This is also not going to be possible because this is a 2 by 3 matrix. This is a 3 by 2 matrix. Because the dimensions aren't exactly the same, I can only add a 2 by 3 matrix to another 2 by 3 matrix. This is also going to be not possible. Can't be done. You can't add these together. My calculator will know this as equally as well. If I do second matrix and get first the E highlighted with names and hit enter, onto G. Second matrix, get the E highlighted, and then second matrix, get the F highlighted. When I have E plus F on my calculator and I hit enter, it's going to tell me that also can't be done. So it gives me an error message, so it's not possible. That's the easy part. Scalar multiplication, addition, and subtraction are just defined logically in my mind. You know, adding components that are in the same places, multiplying everything in the matrix by the same number. That just intuitively makes sense to me. Matrix multiplication is bizarrely defined. And let me first do the matrix multiplication on my calculator to generate an answer, and then I'm going to show you how to do it by hand. So problem 16 wants me to take matrix B times matrix A, which is going to take the matrix 4, 5, 1, 2 times the matrix -2, 4, 3, 1. If you've never seen matrix multiplication before, you'd probably think this is the answer. And this would be the most common wrong answer. If I was going to define matrix multiplication, I would define it like this. I'd go 4 times -2 is -8. 5 times 4 is 20. 1 times 3 is 3. 2 times 1 is 2. Then I'd be done. Unfortunately, that's not how matrix multiplication is defined. I'll generate an answer via my calculator real quickly. I'm going to go second matrix, get B written first. And then I don't need a symbol for multiplication. If I write two matrix names next to each other without a symbol, the multiplication is implied. So second matrix A. So that's my problem, B times A. And when I hit enter, it's going to tell me the answer that I'm going for. And I don't think any of the four numbers here are going to be right. When I hit enter, it tells me the answer is 7, 21, 4, and 6. I would suspect that if I gave you the better part of an hour and asked you to go from the problem to the answer without telling you how matrix multiplication is defined, that most of you couldn't get the numbers because they're not intuitive. It's not by any stretch of the matter intuitive. So to do matrix multiplication, first thing I do is I'm going to get one row at a time. My answer has a top row and a bottom row. And I'm going to get my numbers one number at a time. To get my top row, I need to use the top row of the B matrix. I'm going to take this top row and write it as a column. So I take the 4, 5 top row of the B matrix, write it as a column, and next to that 4, 5, first I'm going to put the -2, -3, which is the first column of the A matrix. I'm going to put a time sign between. I'm going to take the top column, the top row, times the first column. When I do this, I'm going to go 4 times -2 is -8. 5 times 3 is 15. Do those two multiplications. Now add these numbers. -8 plus 15 is +7. If you look in my answer, there's the +7. Again, that's not intuitive to me at all. Why would you think to do that? But that's the way matrix multiplication is defined. Next, I'm going to take the 4, 5, write it again as a column, but this time write it next to the 4, 1 column. Put a little time sign, write the 4, 1 column. I'm going to multiply 4 times 4 and get 16. Multiply 5 times 1 and get 5. Add those two numbers together. 16 plus 5 is 21. There's the 21 that my answer came up with. I'm done with the top row of the B matrix. Now I'm going to move on to the bottom row of the B matrix and get the bottom row of my answer. The bottom row of the B matrix has 1, 2. I'm going to write that as a column. And I'm going to do the same thing. I'm going to write it next to the first column, which is -2, 3. When I do that, I'm going to multiply 1 times -2 and get -2. 2 times 3 and get 6. I'm going to add -2 plus 6. Those have opposite signs, so I subtract and take the sign of the larger and get a 4. And then I'm going to take the 1, 2 again and write it vertically and put it next to the 4, 1. Multiply 1 times 4 is 4. 2 times 1 is 2. After I do the multiplications, I add and get the 6. So here's the 4 pieces of my answer. There's the 7 and 21 that make up the top row. Here's the 4, and the 6 that make up the bottom row. So the answer is 7, 21, 4, and 6. It's not what I thought might be the answer because matrix multiplication is defined bizarrely. You take rows and make them into columns and multiply them by the other columns. So for each of these multiplication problems, I'm going to make sure I know my answer ahead of time. Next one I'm going to do is E times F. So to do E times F, I take the E matrix, write it first, which is negative 3, 2, 2, 5, negative 1, 3. Multiply it by the F matrix, which is 1, negative 2, 5, 2, 6, 7. It's tempting to say this can't be done because they're not the same size. That's not the case. Let me break out my calculator to see what happens when I do E times F. So second matrix, get the names in the E highlighted and hit enter. And then second matrix, get the names in the F highlighted and hit enter. So that's my calculator's representation of E times F. I have the E matrix and the F matrix, no symbol between, so there's an implied times. And this is supposed to be my answer. My answer is supposed to be 19, 24, 18, and 9. And I'll get it basically the same way. First, I'm going to work on the top row of my answer. I use the top row of the E matrix, write it as a column. So I'm going to take that top row, write it vertically. Now pair it up against the first column in the next matrix. Put a times sign between because that's kind of what I'm doing. So I line these up. I'm going to go negative 3 times 1 is negative 3. 2 times 5 is 10. 2 times 6 is 12. I'm going to add negative 3 plus 10 plus 12. The 10 and 12 is 22 minus 3 is 19. That's the first part of my answer. Now I'm going to take this top row again, write it as a column as negative 3, 2, 2, put it up against this column, negative 2, 2, 7, multiply across. Negative 3 times negative 2 is positive 6. 2 times 2 is 4. 2 times 7 is 14. I'm going to add those three numbers. 6 plus 4 is 10 plus 14 is 24. If you look at my 19 and 24, that 19 and 24, they're the same, and that's not a coincidence. I've turned the top row into both columns, so I'm done with it. Now I'm going to work on the bottom row of the E. I'm going to take this 5, negative 1, 3, write it vertically. First put it next to the 1, 5, 6 column. Do the multiplication. 5 times 1 is 5. Negative 1 times 5 is negative 5. 3 times 6 is 18. Excuse me. Excuse me again. And now I'm going to add these numbers up. 5 plus negative 5 is 0, plus 18 is 18. There's the 18 in my answer. Now I'm going to take this 5, negative 1, 3. Put it next to the negative 2, positive 2, 7. Multiply. 5 times negative 2 is negative 10. Negative 1 times 2 is negative 2. 3 times 7 is 21. Negative 10 and negative 2 is negative 12. Negative 12 plus 21 is 9, which is that. So my top row has 19 and 24 left to right. My bottom row has 18 and 9 left to right. DC is a mess because it's going to give me a 3 by 3 matrix. It's going to take a lot of room. I should probably put it on a new sheet of paper. So number 20 wants me to go D times C. And then I need to know what matrix D and matrix C are. Matrix D is 3, 2, 0, 4, negative 1, 3, 1, negative 5, 6. Matrix C is 1, 0, negative 1, 7, 2, 4, 2, 3, negative 5. I'm going to get an answer on my calculator because this is hard for me to do by hand, and it's not hard to do on my calculator. So I'm going second matrix names, getting the D highlighted first, then second matrix names, getting the C highlighted second. So there's D times C on my calculator, and it's going to give me the answer that I'm shooting for, some reasonably large numbers in there. The answer is supposed to be 17, 4, and 5 for the top row, 3, 7, and negative 23 for the bottom row, negative 22, 8, and negative 51 for the bottom. So I have a top, middle, and bottom row. Top 17, 4, and 5, middle 3, 7, and negative 23, bottom negative 22, 8, and negative 51. The top row of the D matrix is going to get me the top row. So I'm going to take the top row, write it next to each column. So to get the top row in my answer, I use the top row of D. So for the top row, I'm going to take the 3, 2, 0 top row, write it vertically. First write it next to the 1, 7, and 2. And when I write it next to it, I multiply. 3 times 1 is 3. 2 times 7 is 14. 0 times 2 is 0. I add 3 plus 14 plus 0, which is 17. There's the first thing in my top row. Now I'm going to put it next to the 0, 2, 3 column. I'm going to take the 3, 2, 0 top row of D, write it next to the 0, 2, 3 column of C, multiply 3 times 0 and get 0, 2 times 2 and get 4, 0 times 3 and get 0, add 0 plus 4 plus 0 and get 4. There's the 4 in my answer in the top row. But to finish up the 3, 2, 0 by multiplying it by this last column, so I'm going to go 3, 2, 0 times negative 1, 4, negative 5. 3 times negative 1 is negative 3. 2 times 4 is 8. 0 times negative 5 is 0. Add these, negative 3 and 8 is positive 5. So my top row has to be 17, 4, and 5, just like it does. Look, from my calculator. Now I'm going to work on the middle row. I'm done with the top row of D. Top row of D gives me the top row of my answer. The middle row of D gives me the middle row of my answer. I'm going to take the middle row of D and write it as a column. So I'm going to go 4, negative 1, and 3. First put it next to the 1, 7, 2 column. Go 4 times 1 is 4. Negative 1 times 7 is negative 7. 3 times 2 is 6. Add these up. 4 plus negative 7 is negative 3. Negative 3 plus 6 is positive 3, I believe, which is exactly that. Now I'm going to put this 4, negative 1, 3 next to the second column, 0, 2, 3. Multiply across. 4 times 0 is 0. Negative 1 times 2 is negative 2. 3 times 3 is 9. Add these up. The 2 and the 9 have opposite signs. I subtract, take the sign of the larger. Gives me a 7. Last time with the 4, negative 1, 3, I would do 4, negative 1, 3 times this last column of negative 1, 4, negative 5. 4 times negative 1 is negative 4. Negative 1 times 4 is negative 4. 3 times negative 5 is negative 15. All three of those numbers are negative. I'm going to add them and keep them negative. Negative 4 plus negative 4 plus negative 15 is going to be negative 23. So the middle row in my answer is going to be 3, 7, negative 23. And now I'm going to work on the bottom row of my answer. I'm done with the middle row of D. I'm done with the middle row of my answer. Now I'm going to work on the bottom row of D to get the bottom row of my answer. So I'm going to take this negative 1, 5, 6, or 1, negative 5, 6, multiply it by 1, 7, 2. When I do that, 1 times 1 is 1. Negative 5 times 7 is negative 35. 6 times 2 is 12. 13 from 35. I think that comes out to negative 23. It actually comes out to negative 22 apparently. It does. So I did math bad in my head. Nicely, I have my calculator's answer to save my bad math. Now I'm going to take the 1, negative 5, and 6, write it next to the 0, 2, 3. 1 times 0 is 0. Negative 5 times 2 is negative 10. 6 times 3 is 18. The only numbers there I need to worry about are those. Negative 10 and 18, those have opposite signs. I subtract, take the sign of the larger, get that 8. Lastly, I take this 1, negative 5, and 6, multiply it by negative 1, 4, negative 5. 1 times negative 1 is negative 1. Negative 5 times 4 is negative 20. 6 times negative 5 is negative 30. All three of those numbers are negative, so I'm going to add them and keep them negative, and they'll give me the negative 51. So in my bottom row, there's a negative 22, an 8, and a negative 51. So each individual component, you have to get one at a time by taking a row in the left matrix, putting it next to a column in the right matrix. You do the multiplications that are implied. After you're done with the multiplications, you do your addition. It's really a nuisance, matrix multiplication, to say the least. So that was 20. 22 wants me to do A times D, which is a fun problem in some sense. So to do A times D, I take the A matrix, negative 2, 4, 3, 1, write it next to the D matrix, 3, 2, 0, 4, negative 1, 3, 1, negative 5, 6. Check the answer on my calculator, then I'll try to confirm it by hand. So I'm going to go clear this out a little bit. Second matrix A first, and then second matrix D second. So that's my calculator's representation of A times D. When I hit enter, it says dimension mismatch. The answer to this is not going to be possible, which is the best possible answer really for matrix multiplication, because it means I don't really have any work to show. If I tried to do the work that I've been doing, the first thing I would do is take the top row of A, start multiplying it. So I'd be going, I'm going to try to get my top row first. I'm going to take the top row of A, negative 2, 4, and write it as a column, pair it up to the C column, or the D column of 3, 4, and 1. The reason this is called a dimension mismatch is there's no number to multiply this bottom number by. So when I wrote the A matrix, when I write the first row as a column and pair it up against the first column in the D matrix, I don't get this nice clean correspondence. There isn't a matchup. And so when you write the first row as a column and there's a stray number, then it's not possible, and you just stop there. So the answer to this is this just isn't possible, and there isn't any more I have to do. I can show you that it's not possible because I'm circling this is a reason it's not possible, because there's no number to multiply this 1 by. Or you can show any of the turnings. None of the turnings would work properly. So that's the best situation. Again, my calculator tells me dimensions mismatch means that these things don't fit well to multiply. Last problem, I believe, 24. A times F. Good deal. A times F wants me to take the matrix A, which is negative 2, 4, 3, 1, multiply it by the matrix F, which is 1, negative 2, 5, 2, 6, 7. If I'm doing that, the first thing I would do is work on the top row. I'd write the top row, negative 2, 4 as a column. I'd write it right next to the 1, 5, 6, which is the first column of the F matrix. Have the same issue here. This is going to be not possible again, because when I go to write the column row combination next to each other, I get that stray number that's not going to work for me. So matrix multiplication is only possible when you turn the rows of the left matrix that they fit with the columns of the right matrix. When I do AF on my calculator, I'm going to get dimension mismatch again. So on my calculator, if I did second matrix A and then second matrix F to get the problem looking just more or less like I have presented it, and I hit enter, I get dimension mismatch, which means that multiplication is not possible to do. So that's the entire section. The matrix multiplication is the only part that's really tedious, and your calculator, you should know the answer for every single one of these problems, before you even do the problems by hand, because your calculator can generate the answers really quickly. The nice thing is I don't even need to use the matrix math. I just have to use the matrix names to do all the operations in this section. So we just have 2 sections of new material to cover in this chapter. There's another section, I forget the number of it now, that we're just going to skip because I don't think we could properly cover the material in 1 hour. It's material that you do in Math 218. You take about 2 weeks to do a little better version of what we're supposed to do here in 1 lecture, and I just don't feel comfortable teaching the material in 1 lecture, so I'm going to skip that section, and it'll be on the syllabus what section you're going to get to skip. So we have 2 sections of new material in Chapter 8, then the review, then the Chapter 8 test, and then Chapter 9 only has 3 sections of new material and a review. So for the entire semester, we've got 2 sections in Chapter 8 of new material and a review, 3 sections of Chapter 9 of new material and a review. So we only have 5 sections of new material for the entire semester. So we're really getting close to the end. Hopefully you're not losing all your energy, and you can kind of rock on this Chapter 8 test and make it so you don't need too many points on the Chapter 9 test to do well in the class. The final exam is optional. After you take the Chapter 8 test, I'll be able to scribble on top of your test what you need to get on the Chapter 9 test to kind of get whatever grade you're close to. I won't be able to tell you if you can skip the final or not. That's going to be dependent on what you get on the Chapter 8 test or 9 test. But absolutely, after when I return your Chapter 8 test to you, if I haven't scribbled on the top of your test, you need to get 68 on the Chapter 9 test to get an A. If I don't scribble something like that on there, and you can't figure it out yourself, come ask me and I'll tell you exactly where you're at in terms of the class and what you need to maintain the grade without having to take the final. It won't be until after you take the Chapter 9 test that I can tell you 100% for sure or not whether you have to take the final or not, and whether the final can and help your grade or not. All right, that's got to be enough for this morning. Thanks.